Good morning, everyone. Welcome to the summer course. So first of all, I'll introduce myself. So I am Sunit Kumar, your mathematics teacher, and we already started with the first chapter, that is rational number, on Thursday. So we'll continue with where we stopped in the previous class. So let's start the class. So as I said, we'll continue with this chapter, rational number. So we started with this chapter in the previous class, that was on Thursday. And so what we covered in that class was we covered the properties of rational numbers. Two properties we had covered. First was closure property, and second was commutative property on rational numbers. So prerequisite for today's class, that if you want to understand today's class, you should know natural numbers and its properties, so which we have already revised in the previous class. Then you should know the whole numbers and its properties. You should know about integers and its properties. And in today's class, what we are going to do is we are going to continue with properties of rational numbers. So we'll do associative property today, distributive property today, additive and multiplicative identity. What are these? And additive and multiplicative inverse. So this is what we are going to cover in today's class. Okay. So first of all, associative property. So we know that what does associative property mean is that, when you add three numbers or three or more than three numbers, the one, if you choose two out of those three and add them together first and then add the third one, the order in which you are choosing the two, right? This is associative property. So order, if it depends, the answer depends on the order you choose these two numbers, then we say that associative property is not valid here. And if it does not depend on the order in which you are choosing these two numbers out of three, then we say that it follows the associative property. So addition of rational number is associative, and that is for any three rational numbers a, b, and c. If you add b and c first and then add a to it, or if you add a plus b first and then add c to it, the result remains the same. So this property is called associative property. Is it clear, students? So I'll give you one example also. For example, first I'll explain this associative property once again. So when I say addition is associative for rational numbers, so if we have three rational numbers a, b, and c, so first if you add b and c together and then add a to it, or if you add a and b together and then add c to it, the result remains the same. Then we say that it follows the associative property. Okay. Let us take one example. So let's say we have three rational numbers, minus 2 by 3, 3 by 5, and minus 5 by 6. Now, if we add these two numbers first, 3 by 5 and minus 5 by 6, so what will you get the result as? So, you take LCM 6 and 5, LCM is 30, and then, you will have, you will multiply 6 to both of this, you will get 18. And when you multiply 5 to both of this, you will get minus 25. So 18 minus 25 is minus 7 over 30. And then you have minus 2 over 3. Now you take LCM of 3 and 30. Why? Because you will add minus 2 by 3 to the sum of 3 by 5 and minus 5 by 6. So you take 30 as LCM here. You multiply both numerator and denominator by 10. So you will get minus 20 minus 7 is minus 27 over 30. Now, you know that 3 can be, 3 is common in both numerator and denominator. You can cancel 3 here. So you will get 9 here and 10 here. So minus 9 by 10 is the answer here. Is it clear? Now, let's see if we take a pair of minus 2 by 3 and 3 by 5 first, and then add minus 5 by 6. Let's see if the result changes. So when you add minus 2 by 3 and 3 by 5, you take LCM of 3 and 5, it is 15. So you multiply 5 in both numerator and denominator. Here you multiply 3. So you will get minus 10 plus 9 is minus 1 over 15. And then you have minus 5 by 6. We know that LCM of 15 and 6 is 30, right? So now you multiply 2 here in both numerator and denominator and 5 here. So you will get again minus 27 by 30, where if you cancel, the common factor 3 in both numerator and denominator, you get answer as minus 9 by 10. So the order in which you are choosing the two numbers out of three to do the addition first does not affect the result. So that's why we say that addition is associative for rational numbers. Is this clear, students?
Yes, sir.
Okay. So now, so that means if you add 3 by 5 and minus 5 by 6 together first and then add minus 2 by 3, or minus 2 by 3 and 3 by 5 first and then add minus 5 by 6, the result remains the same, that is minus 9 by 10 in both the cases. Okay. So this is associative property for rational numbers. Clear? Let's go to the next one. Now let us check, is subtraction associative for rational numbers? Can someone tell me whether subtraction is associative or not?
No,
Sir,
sir.
it's not, it's associative.
Yeah, it is not associative. You are correct. So subtraction is not associative for rational numbers. Again, let's do it with an example. Let us understand it with an example. So we have, let's say, three rational numbers, minus 2 by 3, 4 by 5, and minus 1 by 2. So what we do is now we are subtracting. So we'll subtract 4 by 5 and 1 by 2 first. So 4 by 5 minus of 1 by 2, we take LCM as 10. So we'll get 8 by 10 and here minus 5 by 10. Okay. So we get 8 minus 5, that is 3 over 10, and minus 2 by 3. Now you take LCM of 3 and 10, we'll have 30. So we'll multiply 10 to both numerator and denominator, we'll have, and here 3. So minus 20 minus 9 is minus 19 over 30, minus 29 over 30, right? So now let's check if we do this association of minus 2 by 3 and 4 by 5 first and then subtract minus 1 by 2 to it. So when we do this association of minus 2 by 3 minus 4 by 5 first, so we'll have the LCM as 15. When we solve this, we'll have minus 10 minus 12, that is minus 22 by 15, right? And minus 1 by 2. Now LCM is 30 here. So we multiply 2 here and 15 to the next one. So we'll have minus 44 minus 15 is minus 59 over 30. So you can see that these two numbers are not same. These two numbers are not same. Because they are not same, we say that subtraction is not associative for rational numbers. Okay. So associative property is not valid for subtraction in case of rational numbers. Is it clear, students? Have you understood the concept that subtraction is not associative for rational numbers?
Yes, sir.
Okay, good. Let's move to the next one now. So every student, I request you to join by your name, followed by your school name, and then followed by your class. Okay. So I think there are few people who have not joined by the school name. Okay. So Akshat and Isabel, please
Sir,
change your name.
sir, my name is Akshay Sharma.
Yeah, Akshat, you have to write your school name also along with your name. So school name
Sir,
underscore.
sir, this is my school name.
No, this is your name which you use in school. The school where you study, you will have to write the name of the school as well. So your
Okay, sir.
name followed by the name of your school and then the grade. Okay.
The Platinum Valley International School.
Okay. Okay. So please write your name also there. Write the school's name as well. Okay.
Okay, sir.
Good. So let's go ahead, students. Now let's come to associative property for multiplication. So multiplication is associative for rational numbers. That is, for three rational numbers A, B, and C, A into B into C. So if you multiply B and C first and then multiply A, or you multiply A and B first and then multiply C, the result is going to be same. So we say that multiplication is associative for rational numbers. Now, if we take this example where you have to multiply, so there are three rational numbers, -7/3, 5/4, and 2/9. If we multiply 5/4 and 2/9 first, we get, so you know that this gets cancelled. So you have, either you cancel it or you can leave it like that. Okay. So you have 10 over 36 multiplied by -7/3. So you have -70/108. Now, here you can cancel both numerator and denominator by 2. You can take out the common factor. So you will have -35/54. Now, what we are going to do is we'll multiply first -7/3 and 5/4 and then multiply 2/9 and let's check the result. So when we multiply -7/3 and 5/4 first, you will have -35/12 into 2/9, which is again -70/108, and you can cancel out 2, which is a common factor in both numerator and denominator. We get -35/54. So that means, the order in which you have chosen the two numbers to multiply first does not matter in terms of final result. So multiplication is said to be associative for rational numbers. Clear, students? So we saw that addition is associative for rational numbers, subtraction is not associative for rational numbers, and multiplication is associative for rational numbers. Okay? Let's go to the next one now. Division. So division is not associative for rational numbers. So subtraction and division are not associative. Addition and multiplication are associative. Now let's check the example here. So let's say we have three numbers, 1/2, -1/3, and 2/5. So what we have done, first we have divided -1/3 by 2/5. So 1/2 divided by, so when you convert division into multiplication, you take a reciprocal of the next number. So -1/3 into 5/2 it will become when you change division to multiplication. 2/5 we'll have to take a reciprocal of that. So we have -5/6. Again, division to multiplication, we take a reciprocal. So 1/2 into -6/5. So which is -3/5. Now let's do let's do the division of first two number first and then do the division by the third number. In that case, when you divide 1/2 by -1/3, we will have -3/2. And now -3/2 divided by 2/5 will give you -3/2 into 5/2. So this is going to give you -15/4. Now these two numbers are not same. So that's why we say that division is not associative for rational numbers. Okay. So when you divide, second and third first, that will not be equal to the result of division of first and second term first. Is it clear, students? Did everyone understand? Okay.
Yes, sir.
Good. Now let's quickly do this illustration. So students, we'll do it one by one. So let us check the addition. Natural number, is it associative for addition?
Yes, sir.
Yes,
Right.
sir.
So if we have 2 plus 3 plus 5, if you add these two first, you will have 5 plus 5, 10. If you add these two first, you will have 2 plus 8 is equal to 10. So this is associative. Okay. So natural number, yes, it is associative. So addition is associative for natural numbers. It is associative for whole numbers. Is it associative for integers also?
Yes, sir.
Yes, it will be associative for integers as well. So because we have seen that it is associative for rational number, it will be associative for integers. Why? Because integers is a subset of rational numbers. All integers are rational numbers. So if it is valid for rational numbers, it will be valid for integers as well. Clear? Now let's go to associative property for subtraction. It is subtraction is not associative for natural numbers. Similarly, whole numbers also it is not. Integers also it is not, and rational number is also it is not. For multiplication, again, it is associative for all four. And for division, again, it is not associative for any of these. Is it clear?
Yes, sir.
So you can check it also, if you have to check 2 divided by 3 divided by 5, for example. So if we do 3 divided by 5 first, you will have 2 divided by 3 by 5 or 2 into 5 by 3, which is 10 over 3. And if you do 2 divided by 3 first and then divided by 5, you will have 2 by 3 divided by 5. That is 2 by 3 into 1 by 5, which is equal to 2 by 15. Is it clear?
Yes, sir.
So these are not same, and that's why we say that division is division is not associative for natural numbers or whole numbers or integers. Shall we move ahead? Shall we go to the next property?
Yes, sir.
Yeah, so I hope associative property is clear to everyone. Now we'll move to the next property. So before we move to the next property, let's quickly do this question, right? So now here, students, there are two ways of doing these kind of question. One is by simply adding them all together, finding the LCM of all these numbers and adding them together. So what are the denominators here? So first we'll do by simple method. So here we know that 7, 11, 21 and 22 are 4 numbers. Let us find the LCM of 7, 11, 21 and 22. You remember how to find the LCM?
Yes, sir.
Great. So let's quickly do it here as well. So we'll write 7, 11, 21 and 22. So we know we'll start with the smallest prime number. Smallest prime number is 2. So we'll have 7, 11, 21 because these are not divisible by 2. 22 is divisible by 2. We'll write it 11. Now the next prime number which can divide one of these is 3. So we'll have 7, 11, 7 and 11, right? Now what we are going to do is we'll divide it by 7. We'll have 1, 11, 1 and 11. And again by 11, we'll have 1, 1, 1 and 1. So the LCM basically is equal to 2 into 3 into 7 into 11. This method, everyone knows this method? Have you read
Yes,
this
sir.
method?
Yes, sir.
Okay.
Sir.
So when you multiply this, we have 7 3s are 21 into 2 is 42. So 42 into 11 will be 462. Okay. So LCM of 7, 11, 21 and 22 is 462. Once we have got the LCM, now what we are going to do is we'll convert each of these fractions to an equivalent rational number with a denominator as 462. So this can be written as 3 by 7. We know that we'll have to multiply this by 66, right? Because 7 is already there. So when you multiply this by 66, both numerator and denominator, we'll have 198 by 462. So let us take 462 as common. 198 plus of, now 11 when multiplied with 42 will give you 462. So 42 into 6 is minus 252 plus of 21 multiplied to 22. So 22 into 8 is 176. So minus 176 plus. Now 22 into 21. Now 21 into 5 will be 105 over 462. Is this step clear to everyone?
Yes, sir.
So once we have done this, we'll add them together. So what we'll do, we'll bring the positive numbers together and negative ones together. So 198 and 105. So this will be 303 minus of 252 and 176 by 462. So 303 minus 428. This is minus 125 by 462. So this is your answer here. Okay. Now what we saw here, that all these calculations were very, very tough, very complicated. It will take time for you to calculate each of these. Everywhere you will have to do a multiplication. Isn't it? Right? So what we are going to do here is, to avoid these multiplication, we are going to use the associative property here. Okay. So two property we are going to use, commutative property as well as associative property. Have you all written this? Can I rub this and do it again using associative and commutative property?
Yes, sir.
Okay. So now what we are doing to, we are going to find pairs which makes the calculations easier. So when we have to use associative property and commutative property, we are going to make pair. Now we know that finding the LCM of 7 and 21 is easier. Similarly, finding LCM of 11 and 22 is easier. So let us bring them together. So 3 by 7 plus of minus 8 by 21. This is one pair, plus minus 6 by 11 plus 5 by 22. We'll make this another pair. Clear? Why we have done that? Again, I'll repeat. 7 and 21, LCM of 7 and 21 is 21, which is easier found because 7 3s are 21. And similarly, LCM of 11 and 22 is 22, again because 11 into 2 is 22. So finding LCM was easier for these numbers, and that's why we have associated them together. Now you take LCM 21 here. So 7 3s are, this will become 9 minus 8 over 21 plus LCM as 22. So we'll have minus 12 plus 5 over 22. Is it clear? So 9 minus 8 is 1 by 21. Minus 12 plus 5 is minus 7 over 22. Now, right, you can write it in bracket. Now it is easier. The calculations have become easier. So 21 and 22, we know that LCM is 462, and 21 times 22 is 462. So you will have 22 minus of 22 into 21 is 462. So we'll multiply by 21 here. So 21 into 7 is 147. So 22 minus 147 will be minus 125 over 462. So did you notice that calculations become easier in this when we associate terms which are easier to find the LCM of?
Yes, sir.
Is everyone clear, and is everyone clear why we are using associative property here and how it is reducing the calculation?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, good. So let's move to the next one, students. Now here in this question, again, we are going to use some property. Which property are we going to use here?
Sir,
Any-
associative for multiplication.
Yes, very good. We'll use associative for multiplication. So which one, rational numbers we are going to associate them together? Which are the two which will associate them together?
So minus 4 by 5 into minus minus 4 by 5 into 15 by 16. 3 by
Okay.
7 is 14 by 9.
So these two will bring them together and these two will bring them together. Why did you choose it like that?
Because sir, 4 and 16 are divisible and 5 and 15 are divisible.
Yes, yes. So 4 and 16 gets cancelled, means there are common factors there, and 5 and 15 again there are common factor there. Similarly, 7 and 14 has common factor and 3 and 9 has common factor which can get cancelled. So the calculation becomes easier. So here, what we are going to do is minus 4 by 5 into 15 by 16. This we are going to do first. And then 3 by 7 into minus 14 by 9. This we are going to do next. Now, let's say we are cancelling this. So 5 3 times and 4 4 times. Similarly, 3 3 times and 7 2 14 by 7 is 2. So this will give you minus 3 over 4 into minus 2 over 3. Clear?
Yes, sir.
So when you cancel this, you negative into negative will give you positive. So this will be 1 over 2. So 1 by 2 is the answer here. Clear, students?
Yes, sir.
Otherwise,
Yes,
what
sir.
you would have to do is you would have to multiply all the numerators and all the denominators, and then finally you would have to divide it and then get the answer. So it would be difficult again. So that's why we have used the associative and commutative property. Clear, students?
Yes, sir.
Okay. Now let's go to the next concept. The role of 0. Okay. So 0 is called the additive identity for rational numbers. It is the additive identity for integers and whole numbers as well. What does additive identity mean? Who is going to tell me?
Sir, me, sir.
Sir, additive
Yes.
identity is a number adds to some number which will result in the number itself.
Can you repeat?
Sir, additive identity means
the additive identity is 0 because any number added to 0 will give that same number.
Okay. So additive identities are those numbers when added to a number gives the same number back to you. Okay. So here in this case, 0 is the additive identity for rational numbers, because any rational number, if you add 0, you will get back the same rational number. Okay. Okay. So for example, let's say we have taken minus 2 by 7 as as a rational number. If we add 0 to it, so minus 2 by 7 plus 0 is equal to 0 plus minus 2 by 7, which gives you minus 2 by 7 only. Okay. Clear? So here, we have also seen this commutative property here and the use of additive identity. So when you add 0 to a rational number, the sum is again the same rational number. Now the role of 1 is called the multiplicative identity, additive identity, and then you have another identity called multiplicative identity. It means that when you multiply 1 to a rational number, you will get back the same rational number. So that's why 1 is called the multiplicative identity of a rational number. So minus 2 by 7, when it is multiplied to 1, it is same as 1 into minus 2 by 7, which is equal to minus 2 by 7. So when you multiply any rational number with 1, you get back the same rational number as the product. Clear? Everyone has understood the concept of additive identity and multiplicative identity?
Yes, sir.
Okay. Did every one of you take the test, diagnostic test on that day?
Yes.
Yes, sir.
Okay. So what I'll do, I'll quickly, take you to the platform basically, right? And there I'll tell you what you have to do today, the homework basically. Can you see this screen?
Yes, sir.
Yes, sir.
So today what you will do, when you go to your dashboard, so you will find this third element, assessments here. Okay. So you will click on assessments, then you will get this practice. Okay. So when you click on this practice, you will have this custom practice. Click on there. Now you have these chapters of mathematics. So because we are doing this chapter, rational numbers, you will come to rational number and you will go to view topics. Okay.
Sir, what
So-
is the name of this app?
This is qanditoday.com. So how many students have not got registered themselves in this Q&I Today app? Can you please raise your hand? Okay. So you have not registered. So you have not taken the proficiency diagnostic test? Okay. So what you need to do is what we'll do, we'll conduct a proficiency diagnostic test. We'll let you know. It is scheduled for Friday, but we'll see if we can do it earlier as well. So we'll conduct this test where once that test is being done, you will have an access to this platform, this app where you can go back and practice. So whatever chapters, whatever topic we are going to do in the class, you will go and practice on the platform so that you understand how much you have grasped, how much concept you have grasped in the class. Okay. So what we'll do, we'll note down your names also. What you can do, you can write your name in the chat also, so that we know that those students who have not taken the diagnostic test, we need to reach out to them and create your login ID and password so that you can take the test first. And so proficiency diagnostic test basically tells the AI platform about yours. So that AI platform will tell you your strength, opportunities, hurdle, and weakness areas. And then we as teachers also get an info of which are the topics where you need assistance from our side. So we'll help you gain confidence on those chapters by making you practice on those particular topics. Okay.
Sir,
So yes.
I've done the diagnostic test, but like I don't have this platform again.
So when you took the diagnostic test, you would have logged in by your credentials, right?
I think so, sir.
Yeah. So the credentials are your login ID and password. You can get in touch with our customer care also. They'll help you. You can write down your name. So please write down your name. Those students who do not have an access to this platform, we'll reach out to you and we'll create your logins. Okay. So we have Povina, Sudipti, Chaitra, okay, Rishmita, Amiz Sai. Okay, good. So those who have an access to the platform, what you need to do is go on this topic, define rational numbers today. You will select this topic and practice for selected topics. Is it clear? When you click on practice, so this is a 30-minute practice. So you have today you have to do 20 questions in 30 minutes. Okay. So this is the topic's name is define rational numbers. Is it clear?
Yes, sir.
Yeah. So under rational numbers, the topic's name is define rational numbers. You have to select this topic and then, do practice on that selected topic. Tomorrow, I am going to ask you whether you have practiced or not, and we'll get to know whether you have practiced or not. Okay. So please do practice. And we'll continue with our class in the next class now. Okay.
Okay, sir.
So students, if you like the class, please give a feedback in the feedback form which is shared with you, and also please register yourself, subscribe our YouTube channel so that you get all these videos which the lectures video which we are taking right now, so that you can revise the concept when you want. Okay. So thank you students, thank you for joining in. Bye and take care. Have a very nice day.